Okay, everybody, welcome back to our statistics course. We are today going to look at sampling methods. However, before we get started, I just want to give a little recap from the first day and work a few problems, make sure everybody's on board with what's going on, some definitions, and that you can work out some problems. So, you have some homework that I assigned out of the first section of material, and I'm just going to look at a few problems. Maybe some of them are in the homework set, maybe some of them aren't. I'm not really concerned with whether or not they're homework assignments or not, because quite frankly I feel like homework is practice, and if you don't do well on the practice, then you'll need to redo it and practice more before you take a test. So this is just a warm-up session, so to speak. So number 6 in the set of questions says, on my book at least, says, a poll conducted 2 months before a presidential election predicted that the Republican candidate would win with a 55% of the vote. 55% of the vote. Okay, so that's what they said according to the poll that was taken of registered voters and yada, yada, yada. The survey said that there was a margin of error of 3 percentage points. Okay, so if we look at that and we consider that margin of error, if you remember the math that we were working on the other day, we said we'll add that 3%, 55% plus 3%, so the most votes that we would expect for the actual election to have for this particular candidate would be about 58%, and then we'll subtract that 3%. So the fewest votes we would expect for that candidate would be around 52%. So our confidence interval, or the range where we expect for the actual election to fall, is 52 to 58% of the votes for this particular candidate. That's what we would expect to see based off of the poll that was done and the margin of error that the company gave us. So the rest of the problem says, however, the Republican candidate lost the election. Okay, and I want to point out something about these homework problems that you've got. This is one of the pages. I'm looking at number 6 here. Good survey, but a bad result. That's the question I'm working on. So if you'll notice, there's no actual directions there. It just says the Republican candidate lost the election. So you might look at that and go, well, what the heck am I supposed to do? So this book is interesting, and it's not the same as the book that you've got through OpenStax. This is just the homework set that I'm giving you. And if you'll notice, it, like here in the concepts and applications, it says, for exercises 11 through 14, each describe a statistical study. In each case, identify the sample population, sample statistics, and the population parameter. So this book tends to give you like directions for a chunk of questions instead of rewriting the directions on every single problem. So for number 6 up here, there aren't any directions. So I need to go back in the set and see what it says. So the beginning of this section says, does it make sense? For exercises 5 through 10, well, ours is number 6, so it's in the middle of that, determine whether the statement makes sense or is clearly true, or does not make sense, so it's clearly false. Okay, so it's either, okay, yeah, we can do that, or no, we can't do that. Explain your choice clearly. Not all of these have definitive answers, so your explanation is more important than your chosen answer. So in other words, if you can justify the answer that you have, then that is really, really, really important. So these directions apply to our problem. So we're saying, look at these numbers. The confidence interval is between 52 to 58% for this candidate. That means that's more than half of the votes going to that candidate. That candidate should have won. Does everybody agree with that? Okay, that's what that means to me. You're well above the halfway mark. So this candidate should have won. by the stats. However, the problem says they lost. Okay, and the question says, does it make sense? Okay, and the title of the problem should maybe give us some clue about what's going on, I hope. It says, this is a good survey, but bad results. So we got, the questions were good, they were valid, which candidate are you going to vote for, blah, 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 got all their demographic information, whatever. So we got information from each person, and their information is good, the survey is good. However, it doesn't make sense. Okay, this does not make sense that this candidate lost. They should have won. So then what do we do? That's the question. What do we do about something like this? Because sometimes bad things happen with our statistics, right? So we then would look at it and go, okay, well, let's go back and look at our sample. The sample is really important. Okay, how did they get their sample? Was it a representative sample? And clearly it wasn't a representative sample. Because if it had been representative of the entire group, then what? It would have been correct, right? Okay, so since our data is correct because we gathered it correctly, our statistics tell us one thing, but reality told us a different thing. That tells us that our sample is probably not good. There are other things that could have happened. Maybe we didn't have a big enough sample, or different things like that, but something tells me that our sample wasn't representative here. So then we would go back and say, was it all one social economic group that we had polled? Were we in one area? For instance, people in Hunt County are going to vote differently than people in Dallas County. Okay, so Hunt County tends to be more conservative. Dallas County tends to be a little more liberal. You might have different groups that are voting in different ways. So, for instance, if this particular candidate said that they were anti some agenda item, and I don't know what it would be, say women's right to vote or something, okay, then guess what? All the women in their area would not vote for them. So if we got a sample that was all men that said, yeah, I'll vote for that guy, but we didn't get enough women in there, then that's going to be a bad thing. Of course, a candidate can't decide whether women can vote or not. It's already been decided 100 years ago. But the point being that maybe we didn't make sure that our sample was a good enough sample. So we got to watch out for those things. Okay, let's look at number 10. I want to look at number 10 in the same area. It says, the producer of a new song surveys 1,000 consumers. Okay, producer surveys 1,000 consumers, and finds that most of them are very enthusiastic about the song. Okay, so 1,000 consumers, this person who produced this music goes and surveys them, lets them listen to the song, and hey, they're all enthusiastic. So she convinces the Sony recording company to promote the song. Okay, does it make sense? Okay, well, there's a little bit of vagueness in here, right? Most are very enthusiastic about the song. We would assume that that's more than 50%, right? So actually this is one where I would say you could answer either way. I have a definite opinion about what this would be. But if you said, sure, over 50% like the song, so yes, it would make sense for them to be able to convince the recording company to take care of the song for her. okay, then okay, I can see that. My opinion is that I need a little bit more information, okay? So I would wait. I would not promote this song yet. And there's a couple of reasons why. The numbers are vague, okay? Most are very enthusiastic. I need a percentage, and a margin of error would really help. Okay, so that's going to bug me a little bit. But the other thing is that the producer is going out and surveying 1,000 consumers, but we know nothing about those consumers. And if it's the producer of the song, that's probably like going to a fan base for that particular musician or whatever. So I would think, oh, hang on a second. Are these all people who just love that group no matter what, and they'll take any song that producer produces because they know her or they like her or they like the group, whatever it is? I'm a little bit leery of that. Generally speaking, whenever somebody who's involved in the project does the survey, it's a little bit worrisome to me. Okay, so for me, I would say no, and I need a third party. And I need some real numbers, okay? So what you'll find about these homework sets in this book, at least at the beginning before we get really in depth into the mathematics number crunching, is that there's a lot of writing involved, okay? Like actual English words where you're writing out sentences and stuff like that. You'll notice that neither one of these really has me doing a ton of math, right? It's, does this make sense? Explain your answer. So I have to say, yes, this makes sense, or no, this doesn't make sense, and I need to write that out, and then I need to write out my answer. And then once I've got that, I'll scan that, and I'll upload it into D2L, and then we'll have our homework turned in under that folder. But you really have to watch out for this because if it's vague, I'm not so sure I'll go with it. If there's a third party, if there's not a third party, then I'm worried about it. So number 10, I would take it if you answered either direction, but I'd be a little bit concerned. And I want to do one more. I want to do number 12. Okay. And I'm just going to put this up here because I'm not going to rewrite it. Okay, birth weights is the one. This one is the one that says, hey, tell us what's the population, what's the sample statistic, what's the population parameter, okay? So it says birth weights for 186 randomly selected babies, the average or mean of their birth weights is 3,103 grams based on data from cognitive outcomes of preschool children with prenatal cocaine exposure by this person that was published in that magazine. Okay, so hang on a second. Let's talk about this. This population of kids that we're looking at all had prenatal cocaine exposure. What does that mean? Prenatal cocaine exposure. Well, prenatal means while they're still in the womb, and of course cocaine exposure would mean then that their mother was taking cocaine, right? Okay, so the reason we're concerned about these particular babies is because they were crack babies, basically, is what we would call them in general terms, right? So, for lack of a better word. So they were born probably addicted to cocaine. And then the cognitive outcomes of preschool children, that means we're worried about their mental capacity, right? So cognitive outcomes. So how are they doing? So this is probably a long-term study. They were babies, and then we're probably, they said preschool children. We can't judge their cognitive outcomes until they're old enough to really communicate with us, right? So we want to know how they're doing mental capacity-wise. So this is a group of kids who were exposed to cocaine in the womb, but we're looking at 186 randomly selected babies out of that group, okay? So when you're doing that, you have to be a little bit careful, and we can be really, really, really specific or really, really not specific. In number 12, I'd probably be a little more specific because this is a particular group that's being studied. So whenever they ask me, what's the sample? And what's the population? Okay. The general word would be population is babies, right? And we've got 186 babies in the study. That's my sample. Okay. But you could say generic babies here, but I'm going to be a little more specific to that because they give me this information, babies and you can be more or less specific in prenatal cocaine study. Okay, so that's the population. We're not just pulling kids from all over the place, right? They want to know specifically about these kids who have been exposed to cocaine before they were born. So that's what's going on. Okay, now the sample statistic. Well, what piece of data is in there? Okay, let me pull that back up. Number 12. Baby weights, right? The average baby weight in this group of 186 kids was 3,103 grams. Okay. So that's the sample statistic, right? So think of it this way. All that raw data would be the 186 babies and all of their birth weights. Okay, that's what we're talking about. So that would be the raw data, but average birth weight means we took that raw data and we averaged it, right? We found the mean. So the average birth weight was 3,103 grams. That's the statistic, okay? That's the takeaway from this. Whenever they say, oh, all these kids, and they were in this study, and we looked at 186 of them. I don't know why 186. That's whatever sample they felt was big enough to give them good data. Okay, 186 of them, their average weight was 3,103. Okay, and then the last thing that the question asked for was the population parameter. If you remember, the sample statistic comes directly from the sample, but then we use that to infer information about the population, right? So the sample statistic is a very specific number, but if we've done a good job, the population parameter will be a range of values, right? An interval. We'll have that confidence interval where we can say, oh, the average weight of the population in this study would be this, right? Now, unfortunately, in order to do that population parameter, we need a margin of error, right? And as I look at number 12, they don't say anything at all about a margin of error, okay? So whenever I'm thinking about that problem, I'm like, oh man, they don't have that. I said in the last class meeting, if they don't have it, if they don't have a margin of error, then what you're going to do is say the same thing. Come on, pen. Oh, man. Average birth weight of 3,103 grams. Same thing as the sample statistic. But normally we would say plus or minus the margin of error, right? Okay, that's what we would try to have. But just sometimes we don't get all the information we need in order to be able to do that. So if we don't have all the information we need, then we'll just do what we can, and all we can do is say let the sample statistic reference the population parameter, and we'll deal with it later if we can. Okay, so there's a few problems that just wrap up what we did last time and let us know, okay, this is where we were, and hopefully all of that makes sense, and you've gotten good with the vocabulary, and you read the book, and now you're ready to get that homework done and turned in, and all will be well, okay? So now moving on to section 1.2, which is all about sampling methods. New material. If you have questions about any of the homeworks, you can email me. Sampling methods. Okay, well, before we get to sampling methods here, we need to talk about what a census is. Okay, what is a census is the question. So in general, in America, we use census pretty regularly because we do a 10-year census, right? And in that time, we just had one in 2020. We want to know in our census in America how many people are in each household, how many people are in each school district, that kind of thing. And it helps us to be able to distribute tax money, hopefully in a rather fair way, one would hope, so that everybody gets I don't know, Chromebooks in their school district or whatever. So that's why we do a census in America. But the point being that we want to make sure every person is counted. Okay, that's how we use census in America in general. So for our purposes, for a statistical purpose, what we'll be talking about is a census is a survey that includes every member of your population. Okay, so whenever we were talking about last class period, favorite colors, okay, my favorite color, then whenever I do that particular study, we said, well, is it reasonable for me to say I'm going to survey every person on the A&M Commerce campus, all 16 or 17,000 people? And it's just not reasonable that I'll be able to do that, and it's not necessary, right? For purposes of the U.S. Census, we want to count everybody because we really want to know where people are and where the resources should go. But for purposes of knowing the A&M Commerce favorite color, it's not that vital that I get input from every single person. So I don't need to do a census, and I don't want to do a census, right? It's very time consuming. They're still doing the 2020 census, and it's a year later, right? Because people don't fill them out, and if you don't fill out your census, then people have to go knocking door to door and say, hey, why didn't you fill out your census paperwork? It just takes time, a lot of money, a lot of investment to get that done. And then they have to tabulate the results and do the number crunching still, right? So census just isn't very viable as far as statistics are concerned. Instead, we want to do a representative sample, and that's what I mentioned last time. And there are a lot of ways to get a sample that is representative, that's a valid sample. Okay, there's lots of them. But we're going to focus in on a few of them right now. So why do I want a representative sample? I don't want anything that's biased. Clearly shows the results for all subgroups. That's what I want. That's a representative sample. It's not biased. Okay, so for instance, the other day I said, what if I'm set up outside the cafeteria finding out whose favorite color, or who has what favorite color, and all of a sudden all the football guys come through and they all say, oh, we like green, okay, and I have 50 answers that are green and I only surveyed 100 people, okay, then half of the people are going to say their favorite color is green, but that could be because of something going on with the football group, right? Okay, it doesn't mean that the favorite color on the A&M Commerce campus is green. So I need to watch out for those things that could unfairly bias or unfairly, I don't want to say intimidate, unfairly sway the results of my study. Those things would be not good. Okay, so what is bias? A bias, yeah. A study is biased if the design or implementation of the study, that's 4, implementation of the study tends to favor a certain outcome or results. Okay, so again, if everybody in that one group says green, but then I have more people who say other things, but they are the majority of my sample, then that's going to sway my results and it will favor that one particular answer when that's probably not true for the whole entire population. So I want to watch out for that. Okay, so we got to watch out for certain things. Number one, we want to make sure that our members of our sample don't differ, align, I should say, sorry about that, with the population. Okay, and this would be a lot of demographic stuff. So this is gender, race, ethnicity. For our purposes, it's clubs or groups that they're related with. Remember, we said fraternities and stuff like that. All of those things, we want to make sure that those things are aligned with the population. If they're not, if they are different, then we might have bias. There may be bias. Okay. All right, number 2. We want to make sure that I don't have a personal stake in the outcome. Okay, so in other words, if I'm working with that antidepressant medicine and I really want that antidepressant medicine to work for kids that I'm interviewing, I'm working with, then I should not be the one interviewing because I have a personal stake and that's bad for the outcome of the thing. Okay. Number 3, data needs to be collected in a way that makes sure, in a way that guarantees it's representative. Okay, so in other words, if I'm looking at my sample and I realize, oh man, I've got 50 football guys in here, maybe I need to go around and make sure I have 50 ag guys and 50 band people and 50 volleyball girls and 50 people from from different fraternities and 50 people from different sororities. So I need to make sure that I'm not in some way gathering data in an inappropriate way that will sway those details. Okay, and the last one, I need to make sure your data is reported fairly. It needs to be unbiased. Okay, so in other words, I can't interpret the data just based on the way I want it to work out. Okay. Got to watch out for that. Needs to be reported unbiased. Okay, so I've got another example. A couple of examples that hopefully help us out with this process. So one is, say that we want to know the average height of students in our school. Okay, average height of students in our school. Which is a better representation for the average height of students in our school? Should I pull number 1, or A, I should say, the men's basketball team? Or should I pull B, people in our stats class? Which one do you think is going to be more representative of the entire population of our school? I hope you said, let's pull all the people in my head, in Webster brain. I hear, let's pull all the people in our stats class. And then I would say, well, why? Of course, that's the follow-up question. Be ready for that. Okay, why? And then I would hopefully hear a lot of reasons why. So those reasons can be stuff like, well, the men's basketball team is only men, and men tend to be taller than women in general. So our answers would already be skewed because it's men and no women, whereas there are probably both men and women in our stats class. Okay, that's one of the reasons. What's the other reason? Probably pretty obvious. Basketball players in general tend to be taller than the average person, right? So we have 6 feet, 7 feet, that kind of thing. So basketball players are normally, not always, there are a few that are short like me, okay, that can jump or whatever. But in general, whenever you look at a basketball team, you've got a lot of tall, in this case, guys. But even in women's basketball, if it was even the men's and women's basketball teams that we were surveying, the women's basketball team players would tend to be taller as well, just because basketball players in general are taller than the average student. That's just the fact of life. Okay, so you should have a lot of reasons why there. Okay, another example. Example 2. Okay. Whenever we look at, so this is an off-the-wall thing, whenever we look at ratings for TV shows, man, I don't know what's wrong with my pins here. Ratings for TV shows, and we see, oh, that one's got a this rating or that one's got a that one rating. The TV shows themselves or the networks don't do those ratings, okay? They usually go through a company called Nielsen, okay? And they're the ones who rate and say, okay, I'm trying to think of a current TV show. NCIS is the only one that's coming to mind, sorry. You can tell what I watch, I guess. So one of the NCISs, and they say, you know, this one has this many viewers, and it's rated this, and blah, 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 blah. Okay. The thing is that the higher the rating, the more a network can charge for advertising. Okay, and we know that to be true. Look at, for instance, the Super Bowl. Whenever you see those commercials for, I don't know, Budweiser or whatever, the Clydesdales going through, you know, they're charging them a lot of money to be able to advertise during the Super Bowl. And that's because it's a very highly rated TV show. Everybody's watching. Well, not everybody, but a lot of people are watching. And so the networks are able to charge more money for ads then, okay? The problem is, if you were paying for an advertisement and you wanted to show off some product that you had, and the network was the one who told you what the rating was, would you trust them? Probably not, right? So I hear you in Webster brain saying, no, I wouldn't trust somebody who gave themselves a rating, right? So the networks can't rate themselves. I mean, they can try, but it's not advisable, right? Okay, and the reason why is because I need, in order for me to trust you, I need a third party to do that rating system, right? And so that's why networks spend lots of money to pay Nielsen to rate their different shows, because they really, really, really want them to give whatever rating there is, so that their people can be, so that their advertisers can be rest assured that that it's all good. That we're not lying to you. We really do have these high rating systems and all of that. Okay. All right. One more example, and then I will move along. Example 3. Okay. In the book it says that as you go to a particular co-ed dorm, which means both guys and girls are living in that dorm, they have a specific numbering system for how they assign for their students to be in that place. So males are assigned to odd numbered rooms and females are assigned to even numbered rooms. So maybe you can say males are in odd numbered rooms, females are evens. Okay. So maybe you could say odds are on one side of the hall and evens are on the other side of the hall, or something like that. Or odds are all in one wing and evens are all in another wing. So maybe I'm going along and I'm surveying and I say to myself, I'm going to go through and select a sample, and we'll find out what kinds of samples these are in a second. And in my sample, I'm going to knock on every 10th door. So that'd be number 10, number 20, number 30, number 40, number 50, and so on. So that sounds like a pretty good system, right? And it seems like I'm going to get a fairly random sample. And it would all be lovely except for this little bit right here. Males are in all the odd numbered rooms. So whenever I do number 10, number 20, number 30, so on and so forth, those are all of them going to be evens, right? So what kind of sample am I going to get? That's right, they're all going to be females. So I'm not going to get, the problem with this, no males in the survey. That's a problem. Okay, so I'm not going to get any males in that survey. So I need to kind of take, and this may not be something that is my fault whenever I set up my survey. I probably maybe don't know that. And so I need to take those things into consideration. And if I can find out their scheme for how they placed males versus females into their dorm rooms, then I can adjust my sample, right? What's a better system? Okay, maybe if I go every fifth. If I go every fifth, that might be better, right? Because then I've got 5, 10, 15, 20, 25, 30, and so on, right? Okay, so that gives me an odd, this will be a girl, this will be a guy, this will be a girl, this will be a guy. So that gives me every other one, male, female, and so that's probably more representative of the residents that live in that dorm, right? Okay. 50% male versus female. And that's a much better scheme than up here where I was doing every 10th, which I might have thought, hey, I'll be good here, there's not a problem. I'm just going to select every 10th. It's a system for me, right? It works, but I would have been in trouble because I would not have had any males in my sample. So that would be a problem. All right. Let's get on with this. Let's talk about these sampling methods. One of the ones that you have probably heard a lot of times is you want a random sample. Random sampling. And that is true. A random sampling is probably the most utilized one possible. Each number, or each, I'll say participant, has an equal chance of being chosen. That's what happens. It's just totally random. There's no criteria whatsoever for how I'm going to pick them. Okay. In our case, if this was A&M Commerce students and I was trying to do the random or the favorite color study, then I would just throw all the campus-wide IDs into a hopper, like a bingo hopper. Okay, pieces of paper into a raffle box, that kind of thing, right? And once I had them in there, I would squish it all around and I would pick numbers at random, their campus-wide IDs. And then once, I don't even know who that person's name is, it's just a number, right? Once I would have that campus-wide ID, I'd go back to a list of stuff, and then I'd find that person and I'd interview that person and find out what their favorite color is. Okay, so this is very, very random. Who knows what would come out of that if I stirred up inside of the hat or the box or whatever, and then I pulled out random stuff. Okay, so very, very random. If you're doing other stuff with this, for instance, I could use on my calculator a random number generator. I could give everybody a number and I could punch on my calculator or make my computer do large number generations, and they just find a number, and then I'd go find, okay, whose campus-wide ID is that, or whose number is associated with the number that the computer stuck out at me. There's no pattern. Okay, very, 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 very random. Okay, no identifiers. Everyone has the same probability of being pulled. So that is a very common way of doing it. The problem is it could be really time-consuming to figure out all those campus-wide IDs, cut them all out, put them on sheets of paper, cut them all out, put them all in a box, and then go back and find out whose campus-wide ID that was and all of that kind of stuff. So I got to watch out for that, okay? But that is probably the most reliable random sample that you will get people from all the different subgroups represented in your sample, okay? Convenience sampling. Convenience sampling. I don't know what's wrong with this pen. It's a new pen. That just makes me mad. All right, convenience sampling. All right, this one is, I actually have a graphic for this one, and I'll show it to you. I like this one a lot. This one is like, I just walk down the street, basically, and when I see people that I want to poll, I say, hey, do you have a minute? Can you answer my question? And and it's very convenient for me because they're just right there. The people come up to me, basically. So here's the picture that I love for this one. Convenience sampling. So you can tell this guy, he's walking his dog down the street. And this girl sticks her head out the window and says, hey, do you support the death penalty? So it's very, very conveniently located for her because he's right outside her window and she can just yell at him and survey him. Now, hopefully she's doing a better job of surveying than that. But I like the graphic for that because it's just funny. And it says you use the results that are readily available. So they just came to me. It's very convenient. Okay, so normally I would say a pollster sets up a table. Or walks around a location. Getting people to take a survey. Okay, so this would be like when we set up our table outside the cafeteria to find out what everybody's favorite color is. It's very convenient for us to just set up our table and have all those people come to me, right? So the subjects come to me. That's nice in general. The problem with it, though, as we saw, was we don't really have much control over what groups come to me. For instance, I remember I was walking out of Lowe's one day and they said, hey, would you take our survey and we'll give you such and such on your whatever next visit, so many % off or whatever. And I did take their survey, but I'm thinking to myself, it's very convenient for them that I'm just walking out of the store here, but there's a problem. First of all, I have to already be in their store for me to take the survey, so they already know I'm a customer. Maybe they wanted to know things about their customers, like what were you, one of their questions was, where were you today? Like, were you in the paint section, or were you in the appliance section, or whatever. So maybe that's what they're trying to find out, is what do our customers come here for, and maybe that's okay. But the other thing was that they offered me an incentive, right? So we'll give you 10 or 20% off your next purchase, whatever it was. And that incentive, you have to watch out for that, because that could be a motivator depending on how much it is. If it's something small, it's not that big of a deal, okay. But sometimes the incentives can be rather large, and then there's an issue, because maybe I'm motivated to give them a certain answer or whatever because they're giving me something. So it could be biased, so you have to watch out for that. All right, the next one, systematic sampling. Okay, this is like what we just talked about with the dorm rooms, where I said, oh, I'm going to go see every 10th person, or I'm going to go see every whatever. So you poll every, put in some number, person. So one of the examples that I have from one of the books that I have says something about people are walking around on the Smithsonian lawn and polling people, and they're actually saying, I'm just going to poll every third person, okay? Well, the problem with that is, it's a good thing. It gives me a little time. I can poll, and then, okay, I polled this person. Now 1, 2 people go by. I'm going to poll that person. 1, 2, and then I'm going to poll that person. So I can do the third person. That's fine. But what happens if 8 people walk by while I'm polling that one person? Okay. Or what if I poll the third person, but they're actually in a group of 5 people? Okay, so it becomes a little bit cumbersome, but it's a good system, because if you do every third person like that, if you had a lot of people and I could do the third person, and then somebody else could do the 6th person, and somebody else could do the 9th person, so that people can't get bias, we're probably going to get a pretty randomized sample, because mine might be a black female, yours might be a Hispanic male, and so on and so forth. So we'll probably get a good mix-up of people, but it can be logistically difficult to do. So that's called systematic sampling. And these two, let me show you these other graphics. I'll go ahead and get them out here. So this one right here is the simple random sampling. Sometimes it's called simple random sampling because it's not a complicated situation. You can tell they just have a computer generating numbers. But here's the idea for the systematic sampling right here. Sorry. Systematic. So I don't want you, I don't want you, I want you. I don't want you, I don't want you, I want you. So it's very systematic. There's a pattern, and that's the big thing on that one, is the pattern. And we got to stick to our pattern, or else we might lose our randomness. Okay. All right, and then there are 2 left, and these are both, I consider them the group ones. So these have groups. Okay, so I put those together whenever I talk about them, and your book does too, so we'll talk about those together. There's 2 different ones. One is called clustering sampling. Okay. So again, remember, these are already in groups. So I'm going to say hospitals. Hospitals in the area. So we can talk about maybe Presby in Greenville, Baylor in Dallas, UT Southwest. Okay, there's a bunch of different ones. Let me get Greenville has Baylor, Scott, and White, right? Or there's a Baylor Scott and White in Garland, I think. Anyway, so different hospitals. And the way that this works is that all of these are their own group. Okay, everything, they're already separated out. If you were doing criminal justice work, I would maybe talk to you about different jails, okay? Hunt County Jail versus the Commerce Police Department versus Sulphur Springs Police Department, different ones. So anything that's going on inside of this group is its own contained thing. Now, they may have crossovers, and Baylor Scott and White may have stuff in common, but they are their own little group already pre-established, okay? So if I was a nursing major and I was going out to find out, I don't know, birth weights of babies. Birth weights of babies, that's kind of repetitive, right? Birth weights in hospitals, let's say that. If that's what I was trying to do, then for the clustering method, what I would do is I would come inside of this group and I would say, okay, I don't want to talk to the people in Greenville. And I would randomly select which hospitals I'm going to do, okay? I don't want to talk to the people in Greenville, and I don't want to do the Garland one. But I want to talk to the people in Baylor, and I want to talk to the people in UT Southwest. And what I'll do is I'll find out all of the baby weights for a particular period, maybe it's a year or whatever, all the babies and their weights that were born at this hospital over the year. Every single one. I can't miss any of them. Inside of this group, all of those babies are clustered, okay? So I'm going to randomly pick one of those groups, and I'm going to figure out every kid that was in there. So it's like a census on the smaller groups. And the group is predetermined. I don't set them up. Okay. That's what I do. So I'm going to say, okay, I'm going to do this group, and maybe some other group. Maybe this is Mount Pleasant. Oops, that should be in there. I'm going to do all of you guys. Okay? So once I pick my groups that I'm going to look at, I do every child. I found out the birth weight of every child in that group. That's called clustering. Okay, now I put these like this because I don't want you to get confused by it. Stratified is different. Stratified is different. So stratified works the same way. To begin with, we have these pre-established groups. Presby, Baylor, UT Southwest, and it can be anything that we have already that's a pre-established group. I just happen to be talking about nurses right now, and the hospitals are a pre-established group that I can look at. But like I said, we can do other things. Like we could talk about all the restaurants in Commerce, and we could go to them and say, how many customers did you have last week or whatever. And so I can do that and figure out inside of my groups that way. Okay, so the stratified is a little different. Whenever I think of stratified, I think about the different tiers in the Earth's layers. Earth layers. Those are called strata, right? Okay, or the different tiers, the different layers that are in the atmosphere, stratosphere, so on and so forth, right? They're different layers, stratified, okay? So what happens with stratified is, so up here, I choose some groups and I do all of them, okay? Here, it's different. I use all the groups and choose a few participants. Okay. So for instance, I'm going to come through here and I'm going to make my layers. Okay. And what I'm going to say is, okay, you want to do stratified sampling? That means you have to go to Presbyterian and pick and we'll figure out what number or percentage of people I need to do. But out of those babies, maybe we want 50 babies. Okay, we'll figure out what that sample size should be, okay? But if I pick 50 from Presby, then I need to pick 50 from Baylor, okay? And those are random, okay? I just randomly pick 50 babies, okay, and I get their birth weights. And then I go to UT Southwestern, and I get 50 there. And then I go to Baylor Scott and White, and I get 50 there. So the difference is, in this case with a stratified, I'm not doing everybody at that location, but I have to do all of the locations. So I have to go to Mount Pleasant and get 50 kids from there, or however many they have. If they only had 34 born last year, I'll get the maximum I can, okay, but up to the number that I've chosen. If we find out that some of the hospitals have widely different numbers of babies, then what we would do in that case is that maybe instead of doing 50 kids, we might do a percentage. Okay, maybe we'll do 10% instead. 10%, 10%, 10%. And then that gives me an equal amount, an equal percentage amount off of all of them. So you're either doing a set number or you're doing a set percentage, okay? So that's the way that works. So inside of those groups, we're picking up a random sampling. So this one up here is a census of each group that I choose. This one up here is a random sampling of every group. That's the difference. So I'll give you some time to think about that, and I'm going to stop this recording, and then I'm going to make a really short recording that talks about an activity I'm going to have you do real quickly, just so we can see it. Here's another visual for what this looks like. So random, there's no pattern for the ones we're picking. So there's guys in yellow tracksuits, there's guys in purple tracksuits, black tracksuits. So there's no pattern for how I pick them in the simple random. For the systematic, it's clear. I started with the second guy, and then I went every third. 1, 2, 3, 1, 2, 3. Very systematic. There is a pattern, right? Here, the stratified, they have them grouped now. See, these guys are in yellow, these guys are in gold, these guys are in green. And then in the stratified, look, they went in and picked 2 here, 2 here, 2 there, 2 there, 2 there, 2 there. But it's very random the way they picked them, right? Because that's stratified. And then the last one, here's the cluster sampling. They're still in groups. These are all my purple, these are all my black, these are all my yellow, all of those guys. But we're going to say, hey, we're not going to worry about the guys in the purple track suits. We're going to pick the guys in the blue and the black. Okay, and all the rest of them we're not worried about. We're going to do a census on the blue and a census on the guys in the black tracksuits. And that's the difference between these two. I'm going to load these images into D2L so you can have a better look at it on your own time. So take a look at that whenever you get a chance. All right, that's it for sampling strategies, except for the little activity I'm going to have you guys do, and I'll do a separate video on that. Thank you. Have a great day. And look in your D2L for what's due. Thanks.